So before we officially look at this topic, let's look at the most important thing arguably about logarithms is what do they mean? Because they're a new type of operation for us, a new type of function. So in this section we finally looked at exponentials where the exponent is the thing you don't know. And so picture just like multiplication and division are opposite of each other, addition, subtraction, taking a square root, squaring something are opposite of each other, logarithms and exponentials are opposite of each other. How logarithm works is it's log base b of y is asking this base to what exponent would give me this answer. So the biggest thing about them is these two are interchangeable. And the way I try to get this to remember what positions everything goes in is first I try to identify the base, since that kind of stands out the most. In fact, let's erase this and we'll try to put it back together. So the base in a logarithm and the base in an exponential stand out, especially because here it's like a little subscript number. And then in an exponential, the base is what we call the thing that the exponent's on. So when I decide what the base is, I write that down first. And then the only other thing I try to remember about it is since a logarithm is asking this base to what exponent would give me this, is that the answer in a logarithm, so whatever's over here, doesn't matter, it could be a whole bunch of stuff or a single letter or number, the answer from a logarithm is an exponent, so that tells me that x, or whatever's over here, becomes my exponent. And then see, because there's only 3 pieces here, once you have 2 of them in the right spot, the other one has to go over here. So it's saying this base to what exponent would give me y. Alright, so then let's look at an actual problem that we're trying to solve. So log base 81 of x equals 1/2. Alright, so first let's identify what's the base. So the base is 81. Log base 81 is how we read that. And then the only other thing I try to remember is that the answer from a logarithm, so this 1/2 is an exponent. So there's my base, there's my exponent, which means the x has to go on the other side of the equation. Notice how this x was trapped in an exponent, or in a logarithm, and now that it's not, this just says 81 to the 1/2, which means the square root of 81, which is what, 9? So if it's written in a form where you can't tell what x is, if you write it in the other form, you can switch from this to this or from this to this. They're the same thing. So x equals 9 would make this work. Alright, let's try another one really quick. So this one says log base x of 1/64 equals 3. So first thing, I identify what's the base. So here x is the base. Sometimes the base can be the thing you don't know. And then I remember the answer from a logarithm is an exponent. So that means this 3 is an exponent. So here's the base, here's the exponent, which means the 1/64 has to go on the other side. And then what can I do to get x by itself? Well, this says x to the 1/3 is 1/64, so we'll take the third root of both sides. Or it's the same as putting both sides to the third power. So third root of 1 is 1, and third root of 64 is 4, because 4 to the third gives you 64. So the biggest thing is that rearranging. I try to focus on the base and then the exponent first. There's only 2 out of 3 pieces. Once you have 2 pieces of it in the right spot, then the other one has to go in the other, the leftover spot.